Oh, wow. Okay, very good. Yes. Log base a of x literally means a to what power is equal to x. So we just came out of polynomials where we said, for example, x cubed is equal to 64. Well, what do you cube to get 64? 4. Very good. X is 4 in that scenario. Well, now what we're thinking about is this. 4 to what power is equal to 64? 4 to the third. So what you just did was a logarithm. A logarithm solves for exponents. And you say, no big deal, Mr. Gens, I could do that in my sleep. And so then I say, okay, 4 to what power is equal to 40? Right? Even with your calculator, many of you would struggle to be able to solve that. Okay? And so that's challenging. You know that 4 squared is 16. You know, 4 to the third is 64. So it's probably between 2 and 3, right? But who knows exactly what it is? That's difficult to understand. So logarithms help us be able to answer that question, that challenging question. So log base a of x means a to what power is x? So these are currently logarithms. It says log base 2 of 32 is equal to 5. Or base 2 with an exponent of 5 is equal to 32. So you can take logarithms and write them in exponential form, and you can take exponentials and write them in logarithmic form. So right now this is a logarithm. Now it's written in exponential form. So next one would be what? The next one would be, next one. Ooh, what's different about this? ln. Okay. Notice the base. The base is determined as 2 or 3 or 6 or 12. This one doesn't have a base, does it? Okay, the assumed base for all logarithms, for example, log of 100 is equal to 2. The assumed base is 10, and we don't write it. In these situations, we change the base from 10 to 2, 6, 12, whatever it might be. If we say natural log, well, the natural log of, say, e squared is actually equal to 2. The base is e, or 2.71. So you could rewrite this as log base e of e is equal to 1. So how would you write that as an exponent? Very good. So this is log base e of 1. I'm sorry. Yeah, log base e of 1 is equal to 0. So e to the 0 is equal to 1. Now, some people wonder, why is it ln if we say natural logarithm? Well, I think in Latin or French or whenever they first did this, it was actually written as logarithm natural. So we like to put the, like, what? Short man, right? We like to put the adjective in front of the noun, right? But in other languages, they like to put the adjective afterward, okay? So just really depends on how they do it, okay? Let's switch it up. Express the following in logarithmic form. So log, I choose my base. What is the base in this scenario? Log base 2 of 16 is equal to, right. So I always remember, I put the base right where it's supposed to go, right in the bottom, base in the bottom, and the exponent goes at the end, because logarithms solve for exponents. This would be log, I don't need to include the base, because the base is, so log of 100,000 is equal to, and sure enough, on your calculator, you do have a button for log. It says logarithm of 100,000 is equal to 5. Whoop, I did 10,000, sorry. You get the point? Okay. Now it doesn't tell us 4 to what power is 40. That's a little bit more challenging of a question for us. Okay. But here we have log base of is equal to. Great. Nope. Log base of. Good. Log base of is equal to -1. And what's my base here? So natural log of e is equal to 1. So the first understanding of logarithms come with understanding exponentials and rewriting them back and forth. Everybody okay with that? Okay, now let's go to some of the more critical points of today. Flip to the very last sheet that you have. Okay, some things I want to point out to you on this sheet of notes to kind of organize some important properties. These are things you'll take into calculus with you. But does it make sense that log base a of 1 is equal to 0? Why? This is saying anything to the 0 power is 1. Good. Does it make sense that log base a of a is 1? Because a to the first power is a. Now here's where it gets a little bit different. And this is where I need to bring up an important point, extremely important if you want to understand what logarithms are, that you think about this. Logarithms and exponentials are inverses. Let's refresh ourselves what inverses are. Remember, we have so many operations: addition, subtraction, multiplication, division, exponents, square roots. We did composition of functions. We did inverse of functions. We have sine of stuff. We have tangent of stuff. We also have logarithms. So just like these are operations, logarithms are operations as well. If I want to solve 2x equals 6, what do I do to both sides? Or multiply by a half. Why? Because 1/2 and 2 are inverses of each other in multiplication. I'm left with x equals 3. How do I solve this? Or I add -3. Why? Because -3 and +3 are inverses under addition. They help us solve. And you notice they just go away, right? Now, I understand it's easy for you to think about why those just go away, or why that just goes away. Because we can actually group objects together and count them, right? It's easy to think about how that goes away. But logarithms, totally different scenario. Here's what it means for them to be inverses. Log base a of a to the x, log base a and a go away, leaving you with just x equals x. See that? Yep, if the bases match up, they cancel. Kind of like a to the log base a, those go away, leaving you with just x. Like, for example, if I have, okay, excellent question. I'm going to go to a direct example so we can understand this. Look at this example right here, okay? I go back to right where we started. Log base 2 of 35 is or 32 is equal to 5. You guys all said that means that 2 to the 5th power is equal to 32, correct? So watch, Grace. This means log base 2. Can I rewrite 32 as a base of 2? 2 to the 5th, right? Look, those cancel. That gives you 5. Watch me do it again. Log base 6 of 6 to the 2nd power. That's what 36 is, right? Those cancel, leaving you with 2. That's the relationship. Now I'm going to ask you a very challenging question. Okay, 7 to the log base 7 of 4. What's that answer? Those cancel and give you 4. Oh, yeah, that looks really complicated when I look at it, but as long as you know the relationship between inverses, they go away. They cancel each other. You might be like, well, why do they just cancel? Well, why did the 1/2 and the 2 cancel here? Because they're inverses of each other. Okay? That's why that happens. So, what's that? Let's try this part, okay? Log base 4 of 64. I'm going to rewrite 64 so it has a base of 4. 4 to the 3rd. So I have an exponential, I have a logarithm, they undo each other, and I'm left with 3. Log base 3 of 3 to the 3 to what power is 1/9? -2. You can see those cancel, leaving you with -2. These already have the same base, don't they? So it's 8 to the 1st power. So therefore the 8's cancel, and I'm left with 1. Now let's look at problems that you could get on the ACT exam that would look extremely confusing, but are actually quite simple. Log base 5 of 5 to the x plus y. Yeah. Now you get it, that looks like it'd be super confusing, right? Turns out it's no big deal. How about the next one? Sweet. Some people will look at that and be like, oh, I'm done. All I can do is guess. But we're like, hey, I know that. That's a point for me. This one I got to rewrite as natural log of e to what power? It says ln. -2, okay? What's the base of natural log? E. So those will cancel, leaving you with -2. Yeah, very good. Well said. Deceptively simple. Thank you. Once you know the property of inverses, makes it really nice. All right, let's kind of play around here a little bit and find x. Is log base 2 of x is equal to 3. What do you think x is? That means 2 to what power? 3rd power is equal to x. So what is x? 8. See if you can figure out B, C, D, E, and F. Go. Okay, I bet everybody got B. X is 10. I bet everybody got C. X is 3. Any question on B or C? Let's look at D. Did anybody by chance put 7 for X? Nobody? First class ever. Why would somebody maybe put 7? Yeah, because the square root of 49 is 7. But this is saying, what do you take the square root of to get 49? So you had to square 49 to get 2,401. No. This is saying 2 to what power is 0? Can you take 2 to the power to get 0? I challenge you to come up with something. Give me a number. Do you know how we know that that's true? What does the graph of y equals 2x look like? We did this on Friday. What point does it pass through? 0, 1. And you said it approaches 0 but never touches, right? So you can't get 0 out. No solution. And the last one you could write is 1 over 1,000 or 0.001. Okay. So we looked at kind of rewriting them and solving for some pieces. Let's look at the logarithmic function, okay? You don't have to write this down, but this is where you should have some definite aha moments, folks. Definite aha moments. Okay, these two functions are inverses of each other. I'm going to start by graphing y is equal to 10 to the x. This should be a review from Friday. Tell me, what point does it pass through? 0, 1. Okay? And it starts low and it finishes up. Agreed? So it has a horizontal asymptote of y is equal to 0. What's the domain? What is the range? Okay. This is where it all happens for you or doesn't happen for you, okay? What is the relationship between logarithms and exponential functions? They're inverses. Oh, hey, I think I remember my teacher in chapter 2 telling me something about inverses. What happens for inverses with the domain and the range? They switch spots, don't they? So if we want to talk about the logarithmic function, the domain and the range flip spots. So the domain becomes 0 to infinity. The range becomes all real numbers. Hey, what did we do to the x and y values when we found inverses? We switched them, right? So instead of a horizontal asymptote of y equals 0, it's going to have a vertical asymptote of x equals 0. Oh gosh, so this has a vertical asymptote of x equals 0. This graph went through 0, 1, so the logarithmic graph is going to go through 1, 0. And you remember that inverses are reflected over the line y is equal to x. So if you know the exponential function, you know the logarithmic function. It's simply the inverse. If we took them and we graphed them together, that's what we get. So okay, let's actually find some equations. So we have y is equal to log base a of x. And so we want to write an equation for it. So we want, like, say, y is equal to log base 2 of x. Or y is equal to log base 7 of x. Or y is equal to log of x that has a base of 10. Or y is equal to natural log of x. So we want our answers to look like that. Why am I so emphatic about writing this? It's about 25% of students get this wrong on the test, which I feel bad about, and I'm trying to help you from making that mistake. Okay, what do you notice about all these functions? They go through what point? They go through 1, 0, because they're logarithmic functions. They go through 1, 0. So I'm going to look at the second point. Okay? So this is the x value. This is the y value. So 2 is equal to log base a of 25. So that means, what number do I square to get 25? I square 5 to get 25, right? So a is 5. Is everybody in agreement there? You write that on the test. I take a point off because you've not written a function. The function needs to be in that form. So y is equal to what? Log base 5 of x. I need a y in there. I need an x in there. Okay, we'll try again. Is everybody okay with this step? So this is asking, what number do you square to get 25? I square 5 to get 25. What number do I square to get 25? Okay, so look, it says right here, write it in the form of y equals log base a of x. So what do you put in place of a? 5. So y equals log base 5 of x. So if I asked you to write an equation y equals mx plus b, okay, and you wrote for me y is equal to 3x plus 1, you would say, well, that's a line with a slope of 3 with a y-intercept of 1, right? Okay. Now here's the equivalent. So sometimes people write this on the test. They go 2 is equal to log base 5 of 25. Great, but that's not a function. What if on a test I told you write me an equation for a line, but you wrote this instead? Okay. You know that the point 1, 4 is on that line. Suppose you wrote your answer like this: 4 is equal to 3 times 1 plus 1. Think I'd give you points for that being an equation for a line? No. This is an equation for a line. It has an input, it has an output. This is an equation for a logarithmic function. It has an input, it has an output. We can actually graph it. If I told you write an equation that has a slope of 3 and a y-intercept of 2, you would write y is equal to 3x plus 2, right? You wouldn't just get rid of the x and the y, would you? Same thing here. The x and the y are the input and the output. That's what makes it a function. Okay. All right, let's try B. So it goes through 1/6 and -1. So this is my x value, this is my y value. -1 equals log base a of. So this means what number do you take to the -1 power to get 1/6? So 6 is that number. Very good, Will. So y equals log base 6 of x. That's my function. Try C and D on your own. Try C and D on your own. Okay, so for letter C, you should come up with base 10. So you have y equals log base 10 of x, or y equals log of x. Yep, either way is fine. Okay, and this one, y equals log base 7 of x. Any questions on those two? What's that? Oh, how do we get 7? So this means what number do you take to the first power to get 7? What number do we take the first power to get 7? 7. All right, flip it over. Last part. Okay, now we want to look at the graphs. We want to identify the domain, range, the asymptotes, and one point on the graph. Let's consider the parent function. The parent function has a vertical asymptote. It passes through 1, 0. So, what's the transformation that's taking place here? Yep, the exponential would go on the other side. So, what's the shift here? Am I going up, down, right, left, flip? Up 2. So if I go up 2, what will that point change to? 1, 2. Very good. And will that change the vertical asymptote? No, it won't. So you can see the new graph just goes through 1, 2. So this is plus 2, so that means I'm shifting up 2 units. So if it's going through 1, 0, it's going to shift up 2, so 1, 2 instead. No, I'm sorry, I didn't draw it very well then. It does not go through 0, 1 anymore. It does not go through 1, 0 anymore. It goes through the point 1, 2. Right here. So I'm going to take this coordinate and I'm going to move it up 2 units. However you think of it, I just add 2 to the y value. Yep. So what's the domain? 0 to infinity. What's the range? And then it has a vertical asymptote of x is equal to 0. How is letter B going to be different? Right 2 units. So if it used to pass through 1, 0, what's it going to pass through now? 3, 0. So it used to pass through 1, 0. It shifted to the right 2. So if I move 1, 0, 2 units to the right, that's going to be 3, 0. If I move it to the right, will that change the asymptote? Yes, if I move it 2 units to the right, that's going to move the asymptote where? To 2. Leiwa, you had a question? No. So we won't, the base only changes kind of how steep it is, but we won't be drawing that. So very good point. So the base was 10, base is 3, base is E. We're not going to let that really affect our graph so much. Okay. All right. So great, we've got that. Okay, so domain 2 to infinity, range, all real numbers, and vertical asymptote, x equals 2. Right. So that's a question that Leiwa is extending. He's saying, how would this 3 affect it? That they gave you an additional point to show you how the base affected the graph. Okay. So for example, you knew that 2 to the x went through the point 0, 1. Right? It also goes through the point 1, 2. It also goes through the point 2, 4. Also goes through point 3, 8. Right? So they were giving an additional point to show which would be different for y equals 3 to the x. Does y equals 3 to the x go through 0, 1? Yes. But does it go through 1, 2? No, it doesn't. So they would give an additional point just to show how it's different. I'm not asking that you guys do that. Okay, what's different about letter C? Yep, natural log. That's really not going to change the shape so much. What does the x plus 1 do? Left 1, what does the minus 3 do? So if the old location was 1, 0 that it went through, where's it going to go through now? 0, negative 3. If I moved it back 1, will that change the vertical asymptote? Yeah. Moves it to negative 1. Yep. And then, what does the negative sign out in front do? So the vertical asymptote used to be at 0, right? So if I move it back 1, it's going to sit at negative 1. I'm taking this coordinate right here, 1, 0, and I'm going to move it right 1, left 1 and down 3. So left 1 would be at 0, right? And then down 3 would be at negative 3. Okay, and since it's negative, will it start down and finish up, or start up and finish down? Let's skip D and F, but let's do E together. Oh, yes. So domain would be range is going to be all real numbers for our logarithmic graphs, and the vertical asymptote you try letter E on your own. So the parent function says that we start down, we head up like that. So since there's not a negative here, we're going to continue with that shape, because the negative out front makes a vertical flip. So you can see we have a domain of -1 infinity. Our range is all real numbers. Our vertical asymptote is x is equal to -1. It should pass through the point 0, -2. 0, -2. Okay. Any questions on letter E? Just running short on time. Okay, let's find some homework. There we go. All right. So 1 through 29 odd should be pretty quick. Kind of like when we said 4 to what power is 64? Is it x equal to 3? A lot of those problems are just like that. Okay. 35 to 44 is we're going to look at the graphs. Some of them are matching. The other ones you write equations for just like we did. Okay. There's going to be a pretty quick turnaround in here. What is the last day you can retake a test in this class? The 7th, which is Thursday. If you'd like to have a study guide and redo something, please come and find me and let me know. Trying to think of anything else. Oh, the test in this class, it's only 5 lessons in length. We're done with 2 of them. Your test is going to be early next week, Monday or Tuesday. So you'll be able to get the study guide here before the end of the week. It's going to be a quick turnaround. And then after that point, all we really do is we have to cover a couple lessons and get ready for your final exam, and you are done. So, the first semester will be over with. So, no Haney test this week, right? So, great week to spend some time on math.